We're ready to start Unit 3 of Geometry, and it's all about triangle congruence. And in this next section of Chapter 5 that we're going to take a look at, it talks about polygons in general, but this unit really is specific to triangles. So the first thing that they remind us of is rigid motion, and what rigid motion means is that it's a transformation that preserves or keeps the length and the angle measure. So when we talk about a translation, remember we're talking about a slide, we're talking about a reflection or a mirror or a flip, and then a rotation is a turn. But all of those keep that length and angle measure. It preserves it, so it doesn't change the actual shape in size. So that's important to remember rigid motion. The other piece is talking about corresponding parts, and corresponding parts is just talking about the parts that match. So what happens in a rigid motion is that it maps each part of a figure. So for instance, if I had a shape and I chose to slide or translate it, that shape is going to stay exactly the same. So this piece over here is still going to be the same as this piece over here. It didn't change, it didn't morph into something else. It kept the same piece. And remember, in geometry, we mark things the same with those notches. So like if this was the same, this was the same. Those are corresponding or matching parts. And again, it just is talking about here, because rigid motion does that, it preserves the length and angle measure, then I can say that all the corresponding parts are congruent. We can see an example of that here. So we had triangle ABC, and it was reflected over, and now it is triangle DEF. It maintained its size, it maintained everything about it was the same, although my picture doesn't really look like it, sorry, that's okay. So for instance, side AB matches with side DE. It's the same thing, it just mirrored itself over, but it didn't change into a different shape or change its size or anything. Another really important piece is the angles. So the angles, and one way that I can see that here is, for instance, like angle A is in this first place, and in the first place of the other triangle is angle D. Those pieces correspond. So how it's written, triangle ABC or triangle DEF, is actually really important. You can see that angle A and angle D are in those first positions, so they are corresponding or matching. And so we can see that down here as well. A and D match. And then I can see that the second positions here are B and E. So B and E would go together. And then the third and final is the C and the F. Those would match together as well. Just as important are the sides. Remember, with those notches, I can see that this side is the same as this side. And I can see also that AB is in the first two positions, and DE is also in the first two positions. So if sometimes I see a picture and it's like a crazy looking polygon and I can't really tell which side goes with what, if I can see it in the naming of it, I'll be able to tell from the position. Like right now, without even looking at a picture, I could see that side BC has to match or correspond to side EF because they both hold the second and third positions in the naming, so I would know that those are the same. So also remember, in the notches for the sides are the notches for the angles. So for instance, I can see that angle A and angle D are the same, so they get an arc, they get a single arc. B and E are matching or corresponding or congruent, so they would get double arcs. And then those last ones, C and F, would all get triple. So again, that's how we would say in geometry that those are corresponding or that they're the same, without having to write a whole bunch of words. Now, in these properties of congruence, they're going to look familiar because you've seen these properties before, but they're specific to what we're looking at today. So the properties of triangle congruence, we have reflexive. Reflexive, if you remember, it's the same on both sides. So the reflexive property looks pretty much exactly the same when it comes to triangles as well. Triangle ABC is the same as triangle ABC. They're congruent to each other. The symmetric property says that if triangle ABC is the same as DEF, then DEF is the same as ABC. They just flip it around. And again, we've looked at the symmetric property before, but this one's specific to triangles. that if this one's the same as this, then I can say that that one's the same as the first. I can flip them around. And the last one is the transitive property. And if you remember anything about the transitive property, if the first one and the second one are the same, and the second and the third are the same, then it means the first and the third also have to be the same as well. It works the same with triangles. So if ABC is congruent to DEF, and triangle DEF is congruent to JKL, then ABC has to also be the same as JKL. And the last and final theorem for today is theorem 5.4, and it's called the third angle theorem. And it's really more of a common sense, kind of like a shortcut type of a theorem. It states that if two angles of one triangle are the same as two angles of another triangle, then the third angles are also congruent. So you can see here by the notches, they got a little bit messy. But if we say that angle A and angle D are congruent, and angle B and angle E are congruent, if I know these two are congruent to these two, then I can automatically assume that this third one here and this third one here have to be congruent.